Hello, it is Dr. Hakan Satıroğlu. Today we will go through the statistical modeling and machine learning, kind of introduction to the machine learning, and I would like to go another tutorial of machine learning, maybe 2 or 3 more machine tutorial because it's really extensive subject. And yes, statistical modeling is really helpful when we have a data set in your hand, like on the right, you say you see your data could be this kind of data in your hands, and you may wish to model this data is working according to the models. What models we have in mathematics is one of the point at the moment. I would like to introduce. I have 4 of them, and logistic is included because I would like to introduce logistic with machine learning tools. Therefore, it is there. So starting with linear and polynomial and logarithmic. So for people like who doesn't know about them, just I would like to illustrate here is this is the linear model. So your data could be linear, or your data could be polynomial. So as you can see, this is slightly making S figure. I'm gonna emphasize that one by using this tool. Okay, as you can see, okay. Also, polynomial models could have more than like power 2, power 3, power 4. As you can see, power 3, power 2 didn't work. Yeah, power 3 did work, and power 4 worked as well. So somehow my presentation don't show power 2. It should be that way. Let me show you. Or one top or one deep point it should have. If you have a 3 point, so this is wrong, okay? Please consider that one is the correct one. And if you go with a 3, as you can see, this one is showing, I'm gonna make exaggeration. Yeah, one of the point is here and another point is here. It means this graphic has got 2 power x cube. That one has got only 2 powers. So in that sense, so you can, yeah, in that sense, you can have models like mathematical models, or maybe if anyone work on study in analytical mathematics, you need to understand these models, linears, polynomial, also logarithmic function could be as well. It's a logarithmic function. So if I make that, the a little bit different, it's becoming, as you can see, different ways because like quadratic U shape, logarithmic tapering, so some noise. So this is like, the really advanced things, but you don't need to know detail about that. What you need to do is checking your data and put into models and see whether those models, linear, polynomial, logistic, or logarithmic, are sufficiently or parsimoniously giving you enough latent result. Okay? And as you can see, I can say this is like a polynomial. Okay, let me show that one. As you can see, polynomial. It's really fitting. Okay, it's really fitting. But if you propose that one is linear, still you can yield some results. Okay, some results. But as you can see, polynomial is best fitting. Okay. So how you are going to decide whether they are best fitting or not best fitting. Okay, so these are the points are like R square. And I am going to introduce you. I think in my if you have a chance to watch my forecasting video. So these are the terms MAE, MPA, RMSE, and many different values, R square, which is presented here, R square. If R square is high, it means you have good result, okay? So let's click R square with linear. As you can see, R square is 0.06. It's not better fit if you compare relatively polynomial R square. So as already mentioned, polynomial models has got like more than like you can change that polynomial models with different things, okay, different shapes. So this is like the only x square model. So let's include logistics and logarithmic data set. As you can see, this is not like best fitting is polynomial. Okay. So I included in this presentation with different data set. Okay. So let's unclick that one because we've seen only for this data set. Also, if we have a this kind of data set, let's see which one is better. Okay. Click the linear 83, 0.83, polynomial, 0. Yeah, this is a little better, 0.94. Logistic is worse because logistic is a different function. So I included that one to show you some machine learning tools. Therefore, it is here. Okay. Please don't consider that one is the best one for this specific example. So logarithmic function, yeah, logarithmic function is a lot better than polynomial, as you can see. So how you are going to generate these R square, MAE, MAP, Ramsey, or R square values is you don't need to memorize any formulation because computer softwares and programs are making those calculations for you. Before jumping that slides back to slides, I would like to illustrate with another data. Okay, but before to make it clear, your data, if your data in this way, probably that one is the best linear. It usually we can recognize in 98, polynomial 98.1. Logistic doesn't work because and logarithmic doesn't fit at all. Okay. So we illustrated like the different data models. Okay, let's see that one. Linear 75, 75.3. But polynomial, if I improve that one with this cube power, 3 power, it means it's going to better, okay? Because remember, polynomial functions can have more than 3, 4, 5, whatever you add, okay? Even you can add 5, 6, 7 more. But I didn't illustrate them here. Okay, let's check that logarithmic function. Logarithmic function didn't yield a good result, and polynomial is good. Okay, so what you need to do is, what you need to know is R square value should be bigger, is the best fitting. Okay, so when you have in your computer data, when you have data, just what you need to do, you need to put the functions accordingly, and you are going to get that Ramsey, R square, MAE, and so MAE means average errors, means average absolute errors, and these are the explanations exist as well. But you don't need to remember all formulation. It's a computer is doing for you, and we are going to do that Python programming, and we are calculating them. Okay, so this is our practice today. Hopefully, I'm planning to finish in 20 minutes, but I consume maybe 5 minutes here when I was showing the that functions or how they are working. So I'd like to start with churn. Okay, what is churn? Because you may be familiar with this churn, then you can jump this section quickly. Is a video, you can go forward. If you are not aware, you can say churn means customers leaving or stopping a service. So your aim could be to check whether your customers are leaving or stopping a service. So this is your things. Another example, a Netflix subscriber canceling their subscription or not. Okay, you may wish to check your data representing which way. So as you can see, this is not regression, this is not polynomial, but you are offering one kind of like offering one model, then you are testing that model is working or not. Okay, so for example, a bank customer closing their account, a mobile phone user switching to different networks. So these are your models, okay, and you are testing them. So when we are checking with model, like the mathematical or analytical models, so you can say linear regression predict a number. Okay, so this is really essential things to learn, and logistic regressions is predicting probability, which is related with machine learning. Therefore, it is here, as you can imagine. And polynomial is like predict curve numeric trends. This is predict linear trends, okay? And logarithmic curves predict tapering growth. Okay, tapering growth is like this, or this way. So obviously you need to think this is x and y axis. So in example, in linear regression, how many months until a customer leaves? So this is one of the example could be. And will this customer churn? Yes or no? If something is yes or no, in or out, or cancel or not cancel, this is about logistic regression and machine learning as well. Because if you can have more than two options in your data, just keep it simple. For us, logistic regression is machine learning is introduction because of this two options it has. But if you have more than two, it means k-mean analysis, some neural network analysis. So some advanced analysis exist as well. So this is not the part of today's lecture. And polynomial, how does spending change over time before leaving? Okay, probably spending is going to be that way or this way. So you may wish to check whether your data is parallel or parsimoniously giving support on any of them. Okay, so this is your task now. And after this one, what you are going to do, obviously you are going to predict next 1 month sales or next week your customers rate, churn. So this is your aim. Okay, because that's why it is I go with churn here, started with churn. Okay, let's go with the now linear regression. Linear regression is, as we said, that one, obviously it has got some kind of formulation, y, b0, b1, x, plus error term, and this is the mathematical presentation. So all the elements are given you. You can stop and watch. I mean, read them. I don't want to read one by one. Okay. So if beyond the linear regression, alternative regression models exist, multiply regression as well. So in that sense, if the multiply regression exists, so let me do that one. This is for the multiply regression. That x value is becoming more than 1x. So x1, x2. So you need to add here x3 as well. Okay. So this is kind of like more than 1x exists. So maybe you can think that one is like a panel data, but it is not our subject. We are just keeping simple. So choose the model family that matches the data pattern. This is your aim at the beginning. So this data analytics is kind of journey, starting with missing or outliers or checking standardization or normalization. And plus, you need to follow your data is representing which pattern, simple linear, multiply linear, polynomial, logarithmic, exponential regressions. So you need to check them. So, but you don't need to worry about this one because you know that these codes are working for us, luckily. So again, I'm going to use the penguin data set to predict body mass from Flipperland. So body mass and Flipperland is my task is the features are Flipperland. Target output is the body mass. As you can see on this code, this is like it is doing job for you. If you have totally different data set, what I suggest you copy this one and tell LLM model your features and target outcomes and adjust these code according to your data set. Please don't forget in your table, the title field name should be same as should be written here, same as in your Excel file or CSV file. So this is the only bit you need to be careful. So this model is checking linear regression model, whether it's fit or not, X and Y, just, simple regression, I can say. So let's go to that one. So when I run that one, what is asking is about my data. Again, something happened, executing, yeah, comes here. So before jumping choosing the data, I would like to go with these MAE, MAPE, MSE, Ramsey, R square. You can quickly search that one. You can stop them. So these are the mean square errors. So all errors are checked by the means according to the means, and they get squared of them. It means you are exaggerating the errors. So this is the root mean square. It means you are taking sub-square of the errors. So different mentality. So mathematicians made this kind of models. You are going to check them and you are going to decide. So remember, I mentioned R square should be always large. Large is better. So, but there is no option at the moment. We are going to get only one single outcome for the linear model. Okay. Penguin data. Wonderful. It didn't work. Okay, let's run again. Maybe I selected wrong data. Yeah, okay. I think it seems I selected that the first one, XLS, it doesn't work. So these are the outcome. Okay, let's take them down to one of the Excel file. Why you need these? In the meantime, it's opening. So because you are offering kind of like explaining your data, and you need to have some reasoning. What kind of pattern you have? Okay. So this is the aim. So this is for linear regression. Then I'm gonna keep carry on with other stuff as well. And I'll just keep come back to Excel sheet, and we are gonna check whether our data is represented with better for linear or logarithmic function. So okay. Now we get the codes for the linear function is here. It's written if you really want to improve yourself. But I don't suggest you because LLM models are doing job for you. You don't need to learn any coding if you are a business student. But if you are a computer science student, you may wish to advance. Yeah, for sure, go for it. I definitely suggest you. And polynomial regression model. This is another model. Now I'm going to check whether this is, remember that one polynomial x squared. You can have polynomial model is x cube. Oops. Why it doesn't come up? Let me write that back. Oh. I'm clumsy. Sometimes. This is my obsession. So it could be I need to show them in a correct way. So yeah, this is like x with 1 power, then 2 power, third power, okay, as many as you want. But you don't need to remember them. Okay, simply your computer, your things are making calculation for you. This is one of the illustration I brought here. This is linear one, and this is polynomial model. But this is only one polynomial model. Like it is really. Also, you can think that S or S. Those curves are polynomial as well. And as I already said, you're not a mathematician and you don't need to worry about that one. This computer is doing job for you. So let's check whether our penguin data is working or not here. Okay, come back to call up. It helps because my PowerPoint slide don't allow me to copy paste. Okay, I don't know why. So I'm using this one. Now it's gonna work. So literally you can make one program and it's one go and it can check linear, polynomial, logistics, and logarithmic functions, whether their MAE, Ramsey, R-square values are working fine or not, okay? But I'm just representing them separately. Okay, this is the for polynomial one. Let's copy in our Excel sheet. Okay, so I think I need to remind you. So this is degree 2. Okay, I didn't check degree 3. So if you want to run degree 3, so literally you need to change here and you need to check whether okay, let's do that one together as well. It's, I'm gonna type that way, power with 2, okay? This is x power with 3. Okay. And okay, this down down here. And this down. Okay, so literally you can compare now the values. This is the error value is really high for that. Okay, let's do that one is into structure way. All of them is checking error terms, but they are not checking. Yeah, they are checking only error terms. Yes. Did I delete? Go back. I messed up, I think. R square x still good. Ramsey square mean error terms. This is the means of square error terms again. And this is the map is the percentage of the error terms. The mean, yeah, it is checking the mean differences. So I think we can follow up from here. Which one is better now? When you are reporting your analysis, you need to report whether your model is representing linear, polynomial, logistic, or logarithmic function. So it is nice practice. And so as you can see, R square is big is the always best. Remember, the x cube is a lot better than other one, but slightly better than the polynomial with 1 power. Ramsey square is, yeah, this is the cube square is a lot better here because that should be smaller. Okay. Then this one is, okay, I need to zoom that a bit in, I think. That one is okay. So it seems like marginally that one is a lot better up to now. It's better than linear model. When we are modeling, what we were modeling the feature Kalman length explaining the body mass or not. Okay, so this is the two things. What does it mean? This is like x and y axis you can think. Y is the Kalman length, body mass is the x-axis, and program is taking the data and it is just putting on dots on the diagram, and it is checking like coordinates like space. It is putting the points and checking later on whether these data is best fit with linear or polynomial models. Okay, so this is the part. So let's go to another one. Okay, another function is the logarithmic and exponential powers. So I illustrated them here, like linear is that way, logarithmic is that way, and some exponential and logarithmic functions are here as well. I think I need to remove that one because it's making mess. So as you can see, this is the exponential power, exponential function. Okay, because we seen that one is a like polynomial, uh, but the logarithmic function is just opposite of that one. Like mirror, there's a mirror in the middle. Y equals X. This is a mirror, and that blue is becoming red as a like mirroring itself, and it is showing that logarithmic function. It's turning into the logarithmic function. But you don't need to worry about them. Just you need to explain your data is represented with logarithmic function or exponential function. So this is the way. I made some of the explanation here. If you're really interested in, you can read. Just quickly jump to here and check whether this model is better than these alternatives. Okay. What we need to do, we need to go back to collab. To code. Okay, because it's not testing. That's why I'm using this one. Choose the file. Quickly, I can say R square is not better than the other one because as you can see, this R square is larger is better always. Z value is not good, bigger and larger, so it is not. So this is logarithmic function. I think I shouldn't worry about the rest because as you can see, all of them is representing similar things, similar output, and similar trend. But you can have some at some point, you can get some differences because this data set is given to illustrate better understanding for you. But maybe if you come across into some another database, you can get completely different scenario. Okay, so literally you are going to put them into one table and you compare them. Which one is better? Then your data is logarithmic or linear function. Then it's helpful because you will start to estimate and predict your data and next week or next week's sales or next week whether your customer is gonna redundant from your portfolio, okay, or your HR staff, or your staff employee intend to leave, or you can estimate whether next week how many employee you need because you are going to estimate your sales and production line, what kind of product you are going to produce. So these are the estimation and these are the pattern functions you are following. So obviously this is the second section of the analysis, and I think I mentioned about machine learning experiment in the Click application software. It is showing, they have in their software, there's some kind of machine learning and prediction tools, and it's really completely advanced level. Because, when I'm doing one presentation here, this is just only single product for specific location or branch or retail industry. But if you are in a business real world, you will have more than one retail, more than one production line, more than one product or brand, that it is really complicated task. But what we are practicing here, like basic essentials, just we are estimating or predicting or giving modeling for single item, okay? Single item, both of them. But if you are going in a one professional life, you will see things are becoming hectic and you need more advanced and software and they are going to help you Okay, so this is the point I mean. Okay, so but the main technique is like you are checking error terms, um, whether it's working or not. Okay, which one is good? I just show you R square, mean absolute errors, mean absolute percentage of errors, means square errors, mean root mean square errors. Okay, so these are the different techniques, all of them representing almost same things, but yeah. Okay, now go to the logistic regression. It seems I exceeded my targeted time. Um, quickly, I can say because this logistic is really big subject. So maybe I add up today or tomorrow one extra lecture for this one because this is like probabilistic ways are happening in the logistic function. Logistic functions are like you can see patterns are here or here, your dots, and there is no between anything. Just you have two options. It means yes or no, true or wrong. So this is the logistic regression, and we call that one sigmoid function. The model uses a mathematical function called a sigmoid or logistic function to map any real valued number into the range of 0 to 1. So if 0 is here, then 1 is here, or other way around, whatever. This ensures the output can interpret it as a func probability. So application of these logistic regressions are in health care, prediction the likelihood of patient having a specific disease based on risk factors, finance, assessing the probability that loan applicants will default, or identifying fraudulent transaction, marketing, determining whether a customer is likely to click and advertise or subscribes to service. So this function is working for on this one. Okay. And yeah, I think I'm gonna stop here because I don't want to keep longer videos for you guys because it's a bit boring. Yeah, thank you very much for listening, and I'll carry on with logistic regression on the next hour. Take care. Bye bye.